Did you know that NASA collected a sample from an asteroid over 200 million miles away and successfully returned it to Earth? Stay tuned to learn more. Hey everyone, and welcome to XSTEM All Access. My name is Maynard Okereke, also known as the Hop M.D, and I am thrilled to be part of this series showcasing some of the coolest minds in STEM. As your guest host for this episode, I am excited to chat with Dr. Aprille Ericsson. Aprille is an aerospace engineer who has spent over 3 decades at NASA, where she's worked at the cutting edge of some of the space agency's most ambitious endeavors. But she is actually undergoing an exciting career transition. Aprille has been appointed by the President of the United States to serve as the Assistant Secretary of Defense for Science and Technology. In her new role, Aprille will focus on critical, emerging, and disruptive technologies and the STEM workforce associated with them that will boost our nation's technological advantage. You could say she's planning the disruptive technologies that will fuel our future workforce. But before we get into her exciting work, let me tell you a little bit more about myself, because I'm sure you're wondering. I am a science communicator with a background in civil environmental engineering, and I started my platform, Hip Hop Science, to help spark curiosity and excitement in STEM by using music, entertainment, and comedy as tools to educate on a wide variety of subjects. I think curiosity is key to unlocking so many amazing things in life, so I'm always excited to share fascinating things happening in the world of science, which is why I'm so hyped about our interview today, because it's about to take your curiosity to a whole nother level. Please welcome our amazing speaker, Dr. Aprille Ericsson. Welcome. Congratulations on your new role.
Hi, Maynard. Thanks for that great introduction. I really appreciate the opportunity to talk to so many that are interested in hearing about what I do at NASA and my future job.
Let's jump right into our first question. During your 30-plus year career at NASA, you must have witnessed many amazing projects. I wish we had time to cover them all, but I'd like to talk about a few recent developments at NASA that have pushed the boundaries of science and engineering. First is the OSIRIS-Rex mission, which was NASA's first ever attempt to collect a sample from an asteroid and deliver that sample back to Earth. For our audience who may not be familiar with OSIRIS-Rex, here is some background information. The OSIRIS-Rex spacecraft first launched in 2016 and traveled to an asteroid 200 million miles away. The spacecraft arrived at the asteroid in 2018 and spent 2 years orbiting to map and study the terrain. In 2020, the spacecraft collected a sample from the asteroid using a maneuver called TAG, which stands for Touch and Go. During the TAG phase, the spacecraft had only 6 seconds to collect the sample. In November 2023, 7 years after launch, the sample was returned to Earth when the capsule landed in the Utah desert. In total, OSIRIS-Rex traveled 4 billion miles, which is unbelievably impressive. So, Aprille, now that we have some background info about this historic mission, I'd love to hear your perspective as an aerospace and mechanical engineer. What role did mechanical engineering play in the design and development of this spacecraft, which ultimately contributed to the success of this mission?
The OSIRIS-Rex had this challenge of getting to an asteroid, tapping down to do the tag, which is a touch and go. And so that little arm that kind of comes down with a vacuum cleaner basically on the end of it to suck up materials into this sort of vented area, screen-like area, sheet area, that had to be designed by a mechanical engineer. And so structurally, when it taps down, it had to make sure that it doesn't break or snap as it comes down with a little bit of force, but do it soft enough. So you work with an aerospace person who's doing attitude control systems and thrusting the jets to kind of slow down its descent, and then later to touch back up off of it. You have to make sure that it's structurally sound, but also not going to cause a bunch of vibration back through the spacecraft. The vacuum had to be strong enough to suck up this dust particles. And we understand it. Actually, the dust particles, that part worked really well. We had so much samples that it kind of clogged it, even when they began to close it up, and retract it. So they had way more stuff than just inside the compartment inside of this little meshy area. But it worked really, really well, all these different aspects of it. And in terms of the vibration, you have to be careful that whenever you have something you call like a cantilever beam, something that's hanging off of a thing, when you kind of hit it here, it kind of causes this bouncing and wiggling. So you had to be concerned about that. But then you also have to worry about how you package it. How do you get this thing into a nice, tight package? And so we have people that are mechanical electro, which means that they're working on mechanisms, because you need like sort of the avionics piece as well as wiring and components, along with the mechanical aspect of any time you have a mechanism or a device that moves. And you've got an arm, so it's got hinges and it's kind of deployed, so it folds back up. And so anytime you have something like that, you're always worried about a failure because you're bending parts, they all have to work together. And so, yeah, the mechanical engineer had, some tough challenges, but they were able to overcome so many of them. It was really a proud moment for many of us as we watched the opportunity to tag down on an asteroid, grab those samples, and bring them back to Earth.
I can only imagine the pride felt by the thousands of engineers and scientists who worked on this for over a decade. That historic sample is a 4.5 billion-year-old piece of the solar system. Studying it will help us learn about the origins of the solar system and our place in it, which is absolutely phenomenal. Also, here's a fun fact that will blow your mind. Did you know that over 70% of the OSIRIS-Rex sample will be stored away so that future generations can analyze it with improved technologies that don't even exist yet? How dope is that? Okay, I could go on for days with facts, so let's get back to our questions. April, we've all seen the magnificent images from the James Webb Space Telescope that gave us an unprecedented peek into distant galaxies. Can you tell us about your role working on this very ambitious space mission?
Man, James Webb Space Telescope. I started working on it before it was even called James Webb. We called JW. When I first started working on it, it was NGST, Next Generation Space Telescope, and that was close to 25 years ago, but it took 30 plus years to design the James Webb Space Telescope. When I first joined, it was much earlier in my career, and I was doing attitude control systems. So where and how we control the spacecraft's motion, get it in position and maintain that position to take great pictures, in a sense, to be very simple about what James Webb does. And so when I was part of the team, I was working to help purchase the detectors for the near infrared spectrometer, which is a major instrument on board the James Webb Space Telescope. Near infrared, again, is a region of light that we like to look at, but it allows us to kind of see through the cloudy mixtures of stellar gas. And it really is looking at it from a sort of almost a temperature perspective. Like infrared, many of us know when we take our temperature with those infrared sensors, it's able to look at that region of light and measure our temperature. Of course, it's much more to it. There are optics and detectors that get that right signal as it comes down through the instrument. But it was a very critical component. These detectors were very, very expensive. And we're able to now see the many beautiful pictures that you see, but we're also looking backward in time. And that helps us to understand sort of how the evolution of the universe.
So, I actually had a chance to go to NASA Goddard in DC for the actual reveal of the very first images from JWST, and my experience there was absolutely phenomenal. I think the most exciting part for me was just seeing the level of intrigue and curiosity globally from everybody about this new technology. It's like the world was witness to this galactic artistry all together for the very first time, and the buzz was just unbelievable. Now, as we mentioned earlier, you have been recently appointed by the President of the United States to serve as the Assistant Secretary of Defense for Science and Technology at the Department of Defense. How exciting, and congratulations, by the way. Can you give us a snapshot of your new role and tell us why the STEM workforce that serves our country's defense industry is so critical?
Yes, I recently was appointed to be the Assistant Secretary of Defense for Science and Technology. It's a brand new position, and I guess I have to change hats now. I will always be a rocket scientist, but all of the things that I've learned over the years and all of the great things that I've done, for NASA has kind of prepared me for this. I got the luxury again of working with small businesses through the Small Business and Innovator Research programs that our governments provide opportunities for small businesses to help to solve problems. And then the wonderful opportunity to help develop the workforce for research and engineering and help to recruit people to work for the Department of Defense that have a technical background. The department has several labs across the country, so the Department of Defense has technology that is in very infantile development. These are developments that can't be afforded by industry. There's no economic value at the time when we first start them. One of the ones that I love, and I say, oh, this is sexy science, quantum science. Like that is a critical technology under my portfolio that we'll be working hard to advance so that it has applications for our troops. There is biotechnology, advanced materials, and the last one is future G, which we know is 5G and 6G. So all of these will be some of the things in my forefront. I also have 14 other emerging technologies, and I really want to keep an eye on hypersonics. So I'm excited about the opportunity to work with a large workforce to help develop the things that help to protect the United States and our allies. I hope to continue the relationship I have with NASA and use some of the things that I've learned there, but also the great minds that we have at our facilities to maybe help me in my new journey.
Helping to develop the research and engineering workforce for the Department of Defense is a very important job. STEM or technical backgrounds are so key because they really open the doors to so many opportunities in defense. And you don't have to be in uniform or in the military to make an impact on our country's security. Here are actually just a few samples of the technical professionals utilized by the DoD. Speaking of the Department of Defense, the agency focuses on several critical and emerging technology areas that have the potential to revolutionize our country's defense capabilities. One of these technology areas, which you hinted at earlier, is hypersonics. For our audience members, hypersonics is a term to describe things that move really, really fast, faster than the speed of sound. April, can you tell us about hypersonics as it relates to the Department of Defense? What type of technological challenges do engineers face when designing these very complex systems? And what are some potential applications of hypersonics technology beyond the defense sector?
Wow, so hypersonics, yes, it is a very fast moving particle, vehicle, missile. Um, let me just explain, there's two realms when we talk about fast. There's supersonic, which is moving either at the speed of sound or twice the speed of sound. And I'm more familiar with that because NASA actually has something called the X-59 plane that they've been developing to actually help create quiet transportation vehicles that travel at the speed of sound. People that are closer to my age will remember when there was a vehicle called the Concorde, and it was actually a commercial airplane that traveled at supersonic speeds. And so it was really, really fast. And so you had this ability to travel from, say, England, London to, say, New York in just a few hours. Like it reduced the time quite a bit. At the time, though, many were concerned about the sonic boom that happens when you start to travel at the speed of sound, the the air kind of gets compressed and it creates this big boom sound. And so you hear the continuous boom along the travel. So X-59 is looking at that, but it's also got this wonderful pencil-like structure and shape that helps it to travel more smoothly through the air. And I would imagine that some of that knowledge is transferable to hypersonic vehicles as well. And there are capabilities at NASA that I'm hoping that we can reach out to our DLD partners and help to see if there's any way we can help them with them solving the problems that we have with hypersonics. And I'm not saying that we have problems, but we are trying to move quickly to ultimately deliver the technology and the capabilities that our troops need to protect our country. We are concerned that there are other countries that have been working and developing hypersonic missiles. So when you have something that travels that fast, now we're not talking about 2 times the speed of sound. We're talking about anywhere from 2 to 5 times to 10 times the speed of sound. And therefore, you have less ability to react or to protect the country if somebody were to launch that capability into our domain and to send a missile towards us. So we would like to have countermeasures that travel just as fast. And so that's what I see for the future, some way that we're able to protect us against um, another country's hypersonic capability with our own hypersonic missiles or defense capabilities.
I can definitely see why the field of hypersonics is so important to our country and our defense capabilities. For all you students, if you think it sounds cool to work with objects moving up to 10 times the speed of sound and help keep our country safe at the same time, check out these hypersonic focused career options. Now, before we end our conversation today, I'd love to hear your take on upcoming innovations in your field. Do you foresee any technological advancements that will shape the future of aerospace and mechanical engineering?
Yes, I'm always happy to see how technology has grown or made our lives easier and more sustainable in the sense that we're not so wasteful, that we are able to be more efficient with using our resources. And so when I think of the things that I've begun to see in manufacturing and mechanical engineering and 3D printing, we say there are opportunities to make things faster and cheaper, but also more efficiently. So I'll give you some examples. I brought some pieces in to show you. We use a lot of brackets on our spacecraft to hold things down. And so this is one that was designed by a human. It's really pretty heavy because it's pretty solid. It starts off as one big solid piece of metal, and then we cut away. And you'll notice like these 4 holes here, there are 3 holes here. But what we've begun to do is when we're trying to reduce the weight on a spacecraft, like the heavier it weighs, the more it costs us to launch it into space. So we usually do some deduction and cutting away and try to thin it. But if you thin it too much, it's not strong enough and it may bend or break. So we go from how do we do that? And often we have somebody who works on doing it. It takes a lot of time and iteration. But we have one of my colleagues, Ryan McClellan, who I worked on with some other mission stuff. he started to investigate and utilize a new technique that allows the computer to help reduce. Believe it or not, these are for the same purposes. If you see the four holes kind of match up, the three holes on the bottom, but much more lightweight. So even the amount of material that we start with, even that area is a lot less. It will weigh less on board our spacecraft. And then I start to say, man, this is starting to look kind of bony like human structure. And the nice thing is that even though this one was manufactured out of a solid piece, we now go to 3D printing that same thing. And I can kind of show you how the 3D printer, very similar, bone-like. I'm a Star Trek fan, so kind of thought to look like some Klingon type vessel thing here. And then I have one last piece to show you guys, because this is a bunch of brackets. And it looks really interesting. This was made from one piece of solid metal, but you can see there's something here, and there's brackets here, and brackets here, and there, and there. So this is utilized for holding some of our optical elements in place. And Brian did this with a computer.
It's pretty cool to imagine that those parts will all end up in space. You know, we might not automatically think about designing parts to be high tech, but those samples are the work of STEM professionals and engineers who work in the innovative fields of CNC machining and additive manufacturing, or 3D printing. And if you like problem solving, computer design, and enjoy building or fixing things, you should definitely look deeper into CNC machining and additive manufacturing as careers of the future. If you're interested, here's a little more information. I can't wait to see what innovations the future workforce creates in those fields. April, thank you so much for joining us today.
Thanks, Maynard, for the opportunity to talk about what I've done at NASA and my future role at the Department of Defense. It's a wonderful thing whenever I get to talk to students and academics and just the community in general. I say it's a really great opportunity to touch the future. I think so many of you out there are the future and have great ideas, and you can contribute to the many different missions we have across our agency, but help to solve great big problems in our communities and in the world. I often say when diverse ideas collide, they spark innovation. And I hope that many of you, in all your different ways, are allowed to have a voice whenever we need to solve great problems. And anyone can contribute to help solving the many different problems we have in this world and the issues and concerns, but also to create technology to make our lives easier. I also say shoot for the moon, and even if you miss, you'll still be amongst the stars. Um, I say live long and prosper. Thanks from Dr. Ian. Um, Go out there and do great things.
I really enjoyed hearing about your amazing career at NASA and your new role at the Department of Defense, along with the many ways that your career is advancing innovation in the United States. I want to thank you all for tuning in today. Make sure you subscribe to the YouTube channel in the description below and follow us on social media to get updates about new episodes. Trust me, you don't want to miss any of them. Plus, you'll get access to fun weekly content for students and teachers, such as STEM facts for students, classroom tips for teachers, and so much more. And don't forget to check out the full library of episodes available on demand right here. Each one has NGSS aligned lesson plans with an optional SEL component for teachers to use in the classroom. And with your parents' permission, tell us how you were inspired today by tagging us at USA Science Fest, #XSTEM, and me at Hip Hop Science Show. And you can also keep up with me through social media here, where you can find out about upcoming projects and how you can book me for classroom workshops or keynote presentations. I had an absolute blast being your host today, but don't sign off just yet. You'll want to stick around through the end of this video for a fun trivia game that you can do in the classroom or at home. Have fun and good luck.